Okay, so our previous video showed us how to import data from the SYNAPT into PetroOrg software and how to assign chemical formulas to the data with PetroOrg. So this video is going to show us how to go through and sort the data and filter the data based on some constraints that we can set within the software, and then how we can visualize the data with the plot tool located in PetroOrg software. So if we open this N1 class, we see a list of peaks with corresponding molecular formulas. But they are currently listed by molecular weight, and this isn't always the easiest way to visualize these types of data. So what we can do is use the Kendrick sort function to sort by DBE or double bond equivalence. So we come down to the sort button, click the sort button, and then click Kendrick. All right, close. And so now this is going to sort the data based on the DBE value. And you can see every time we see a change in DBE, we get a change from red to blue, which makes it just a little easier to visualize the data. Okay, the other thing we can do is filter out any extraneous data points. We can filter based on DBE and error values. We can also filter based on carbon number and O to C ratio or relative abundance. So for these data, we're going to constrain the DBE between 0 and 50, the error between -5 and 5, and we are going to set this what's called the minimum homologous series. We're going to click this, and we're going to set that to 3 peaks. So basically, we're going to make any assignments have to fall within a DBE series of at least 3 peaks. So we click OK, and this sorts and filters the data for us. And you can see here we've removed some of these low carbon number compounds that are actually just noise peaks that were misassigned. Now there's still some of these types of compounds present, and you can see that they fall outside of the petroleum continuum. So here we have C11, and then we jump to C20. So this is most likely a noise peak. We can go to our spectrum, highlight the N1 class, and we can see that these are our low carbon number peaks. They do not fall within our petroleum distribution, and they are in fact noise peaks, and so we can remove them by right-clicking and hitting delete. This doesn't actually delete peaks, it sends these formulas back to the no-hits. So we're just unassigning these formulas. So here we can select both of these two peaks and click delete. The way we select multiple peaks at one time is by holding Control and left-clicking on the peaks of interest. Okay, so now we've cleaned up the data, but the changes have not been accepted. So in order to apply the changes, we have to come down and click this check mark that says Apply. All right, and now we have filtered out any noise peaks, and we can come back, highlight the N1 compounds, and we see that we've gotten rid of these noise spikes. Okay, so now we want to show you how to plot the data. In order to do so, we come down to the plot button and click Select Single Plot. So we want to select the sample that we're interested in, then click Apply Jobs. And in order to highlight a class for plotting, you're going to click on the class that you want, move it over into the far right box, and then highlight it, and click Plot when you've selected the type of plot that you want. So we have an assortment of plots to choose from. You can choose DBE versus carbon number, and when we click this, we click plot, we can see that we get a plot of DBE versus carbon number, and this is what we call an isoabundance color contour plot. We can also make ion mobility plots, where we're plotting drift time versus DBE, and we can choose our carbon number and show the carbon number distribution here highlighted for each carbon number. We can also look at our error plots to show the error distribution for the compounds that we've assigned, and you can see here that they all fall within 5 ppm. Okay, so that's how you make a single plot. The way you adjust your settings on these plots, you can come into File and go to Options. In the Options box, we can select our range axis, and we can select the range that we want to set for our carbon number. So it will auto adjust this value. If you deselect this box, you can change this value to whatever you choose the values. So we're going to set a minimum of 10 and a maximum of 60 in 10 carbon number increments. On the domain, or our DBE axis, we can go down to range, and we're going to select 0 to 25 with 5 DBE steps, and then click OK. And this is how we can change the axes on our graphs. We can also save these graphs or these images, and there's two options. You can save just the image, or you can save the image with the tick marks present. Okay. All right. Our next video will teach you how to batch plot and how to batch assign multiple PetroOrg data files.